Welcome to this class. In this class, we are going to do examples on application of product rule of differentiation. So the problems are find the derivatives of the following functions. For the first one, y equals to 1 over x into x squared plus e raised power x and then b, we have y equals to e raised power 2x. C, we have y equals to x squared plus 1 times x cubed plus 3. D, we have x power 100 plus 2x power 50 minus 3 into 7x power 8 plus 20x plus 5. So let's discuss the solutions for this. Now, the first problem solution, we have y equals to 1 over x into x squared plus e raised power x. Now, this can be written as x raised power negative 1 x squared plus e raised power x. So that now we let x raised power negative 1 to be u. So let this one to be u and let this one to be v. We know by product rule d dx of u times v is u prime v plus v prime u. So u prime, so our u is x raised power negative 1. So u prime, when you use power rule by the power rule, this one will be negative x raised power minus 2. And v is given by x squared plus e raised power x. So which means v prime will be 2x plus e raised power x. So this means d dx of uv, which is the same as dy dx, is equals to u prime is x raised power negative minus x raised power negative 2 times v x squared plus e raised power x plus v prime is 2x plus e raised power x times u, which is x raised power negative 1. Now this can be written as dy dx equals to negative x squared plus e raised power x over x squared plus 2x plus e raised power x divided by x. I can put this under an LCM. So LCM is x squared. So we'll have negative x squared, negative e raised power x, and then plus 2x squared, and then plus x e raised power x. So this dy dx which will give us dy dx. So dy dx, collecting like terms, so 2x squared minus x will be x squared, and then plus x e raised power x minus e raised power x divided by x squared, which you can write it as x squared over x squared plus x minus 1 e raised power x over x squared. So here the same as 1 plus x minus 1 over x squared, and then e raised power x. So that's the solution for the first problem. B is e raised power 2x. Now b, y equals to e raised power 2x. You see, this is the same as e raised power x times e raised power x, loss of indices. So you let this one to be u, this one to be v. So dy dx will be u prime v plus v prime u. U prime, when you differentiate e raised power x, you get e raised power x times v e raised power x plus v prime e raised power x, derivative is e raised power x times u, which is e raised power x. Now this will give us e raised power loss of indices 2x plus this other one will give us e raised power 2x. So this will be two of them. So this will be 2 e raised power 2x. So this is dy dx. And then number C, C is y equals to x squared plus 1 into x cubed plus 3. So let this one to be u, this one to be v. So dy dx by product rule is u prime v plus v prime u. So dy dx, when you differentiate this one, you get 2x multiplied by x cubed plus 3 plus differentiating this one, you get 3x squared into u x squared plus 1. So opening brackets will be 2x power 4 plus 6x plus 3x power 4 plus 3x squared. Now collecting like terms, we'll have dy dx. 2 plus 3 is 5, so 5x power 4, and then plus 3x squared, and then plus 6x. And then D, we have y is given by x power 100 minus plus 2x power 50 minus 3 and then we have 7x power 8 plus 20x plus 5. So you let this one to be u. This one let it to be u. This one let it to be v. So dy dx will be u prime v plus v prime u. Now dy dx, derivative of this one using power rule is 100 x power 99 plus 100 x power 49. Derivative minus 3 is 0 times v 7x power 8 plus 20x plus 5, and then plus derivative of this one, 7 times 8 is 56, x power 7 plus 20, derivative of 5 is 0, and then multiplied by u, which is x power 100 plus 2x power 50 minus 3. So that will be the answer to the problem. And lastly, E, will have y equals to e raised to x sine of x. Now, solution for this. So we let u to be e raised to x and v to be sine of x. Now, this means that u prime is e raised to x and v prime, derivative of a sine function is a cos function. So by product rule, dy dx is equals to u prime v plus v prime u, which will be u prime is e raised to x, v is sine of x, plus v prime is cos x, u is e raised power x. So this can be written as sine of x plus cosine of x, and then e raised power x. So that will be the solution, or you can write it as e raised power x into sine x plus cos of x. That's how we solve those 5 problems. In the next session, we'll give more examples on product rule. Thank you.